So I am going to draw the motor characteristics curve by using this table that I got it. For your own specification, for your own vehicle parameter, your value could be a different, but I am going to draw the motor characteristics curve using this table, and this will be exactly same as that we got this blue curve, but I got it till 60 kmph, but I'm going to increase this till max speed, which is 110 kmph. Now come back to the fun with vehicle dynamics sheet, and then let's start from the 0 rpm. And from the start, the motor is delivering the torque, which is 94.5, which is this value, and the power I'm going to write in form of formula, which is the multiplication of motor rotational speed in radian per second multiplied by the motor torque, and that's what I have written here. So from 0 to the corner speed, the torque is going to be constant, and I'm just going to increase rpm with the step of 500. So let's go till where? I will go till 3799, or in a approximate way I will go 3800. So after that I can, let's go for 3500 and then just write 3800. Till here the torque is constant, so I will just drag that value, and I will also drag the power value from here, which will be calculated using the formula. Now after this, we know the power is going to be the constant, so let's first set the power here. The power is will be this value, and of course here if you see the power is 37.6. I use it the approximate value and I put it, but you are free to modify this value here, but I'm going to use this value. So let's drag this till the max rpm, which I'm going to get it. Now the rpm again I'm going to increase with the step of 500 till the max speed. What is the max speed of the vehicle that we want to go? 110 kmph, and corresponding motor rpm is 11294, or simply I can write 11300. So let's go at the step of again 500 from here till 11300 rpm. So let's go here. So I got 1130 rpm here, and the torque now I'm going to calculate using formula. What is the formula of the torque? Is nothing but power divided by the rotational speed of the motor in radian per second. So power here I have in a kilowatt, I'm going to convert in watt only. So I have to multiply by 1000. I have to divide this by motor rpm, but I need to convert this in radian per second. For that I need to multiply this motor rpm by 2 pi divided by 60. Yes, and then I just have to drag it till here to here. So this is the peak mode of table that I got it. The next is the continuous mode of the table, which will be the same as what we wrote it here. So I'm just going to copy this value here, and also I'm going to copy the power here. Okay. So now let's go and draw the chart out of this table. So first I'm going to draw the curve for the peak mode, which is torque versus motor rpm. So I will select this two column, go to the insert tab and click this. Then we got a motor characteristics curve for peak mode of operation here. So I'm just going to enable access title, and I am going to write this MOTORQUE Newton meter, and then this I'm going to write MOTOR RPM. We got this motor characteristics curve for the peak mode, which is same as we saw previously in fun with vehicle acceleration curve, but it was still 60 kmph. I just extended this till 110 kmph. Now I'm also going to plot for the continuous mode of operation. So what I will do here, I will click on this chart and I'm going to add the data into it. So come here and then add and write this as continuous, give the x-axis value, give the y-axis value, which is the motor torque, and then done. This is okay. Then click OK. But before that, I will modify the name of this graph and I will write peak mode. Peak mode. Okay. And then I will enable also the legends, and I will just put as a floating legend. Okay, done. We are done here. So finally we got the motor characteristics curve, but before I explain further, I didn't talk about this row, why I wrote 42 Newton meter motor torque, because see here we got which is the rated mode, and then after I just extended as a constant torque mode, and that's what we can say in a continuous mode the motor started delivering 42 Newton meter torque and then went till the rated mode. So that is why I wrote the motor RPM. Of course, it's going to be 0, but the motor torque I wrote the same as I wrote it for the rated mode. So finally, congratulations to you. Finally, you derived the motor characteristics graph and also the table, and then you can use this table to what I call to manufacture your motor or give it to the motor manufacturer. They will design the motor as per this characteristics curve, which will absolutely going to deliver your all the performance parameter that you have already defined it. So congratulations to you. And now we will move to the next set of discussion,